Hi, hello dear students. Good evening all. Welcome to my channel Maths with Panindra. One of our student requested to make the video on definite integration reduction formula, that is integral 0 to pi by 2 sine power nx dx. So how to prove this? But based on this theorem, we may expect 2 marks question. I already did in live sessions. Once you go to the live session videos, you can search that 2 marks videos I provided. But based on the request of one of our students, our subscribers, they're asking to prove this result and one more question also. So I'm expecting the other question also other than this. So how to prove this one? Integral 0 to pi by 2 sine power nx into dx. Whatever the methods we applied in indefinite integration, the same procedure we are going to follow now. Okay. See, first the given integral I am taking as I. Here n is there, no? So in you can assume that. Let it be in. 2 times I am going to rub the board. Dear students, as soon as completing till here, you can take a screenshot, the answer 0 to pi by 2 sine power nx into dx. So this can be written as integral 0 to pi by 2 sine power n minus 1x into sin x dx. Sin x power is 1 only here. So if you multiply these two, you are going to get sin power nx only. In this, n minus 1 is there, no? That is inverse related function. From this step onwards, we are going to apply integration by parts. So, here this is f of x, this is g of x. Here you have to mention that f of x is equal to sine power n minus 1x, differentiate with respect to x, f dash of x equal to n minus 1 into sine power n minus 2x n minus 1 minus 1. Again sin x you have to differentiate cos x, that is f dash of x. Next g of x value is equal to sin x. Okay. From here, by using integration by parts, by for definite integration, dear students, that also I am going to write formula. Integral, general formula I am writing, a to b f of x into g of x into dx equal to f of x into integral g of x dx, applying the limits a to b, minus integral a to b f dash of x into integral g of x dx whole dx. So this is called integration by parts. This formula I am going to apply here. I hope you understand clearly. Very good. So now this is f of x. So in is equal to, according to this, f of x, that means sine power n minus 1x into integral g of x, integral sin x dx, applying the limits 0 to pi by 2, minus integral 0 to pi by 2 f dash of x, whatever f dash of x I wrote here, that we are going to replace here. So n minus 1 into sine power n minus 2x into cos x into integral g of x, integral sin x dx whole dx. Okay. Now sine power n minus 1x integral sin x minus cos x, applying the limits 0 to pi by 2, n minus 1 constant minus n minus 1. Integral sin x is minus cos x. Already minus is there, no plus. Integral 0 to pi by 2 sin power n minus 2x into cos x. Integral sin x is minus cos x. Minus already I have taken. Cos x into cos x is cos square x into dx. In the next step, cos square x I am going to write as 1 minus sin square x. X is equal to pi by 2, substitute sin pi by 2 1, cos pi by 2 0. X equal to 0, substitute. So this complete value goes to be 0. This bracket value, dear students. This bracket value, after applying the limits, this goes to be 0. Plus n minus 1 into integral 0 to pi by 2 sin power n minus 2x into 1 minus sin square x into dx. Are you all with me? Are you able to understand now? So that is equal to n minus 1 integral 0 to n pi by 2 sin power n minus 2x into dx, 1 into dx, minus n minus 1 into integral 0 to pi by 2, bases are equal, power should be added, plus 2 minus 2 get cancelled, sin power nx into dx. So from equation 1, wherever sin power nx is there, replace with in. Okay? One more step, it will be there. So n minus 1 into, this value is, here n is there, here's in we are writing. Here n minus 2 is there, we can write it as in minus 2 minus n minus 1 into in, since from equation 1. Okay, so this is about in. So minus of n minus 1 in bringing this side. I will drop this and I will continue. Yeah, I'll rub this and I will continue here. Till here, I hope you can complete it. I'm going to rub this. How these steps will come, I will explain clearly. So now, here in is there, minus n minus 1 in bringing this side, plus n minus 1 into in is equal to n minus 1 into in minus 2. So in take common, 1 plus n minus 1, which is equal to n minus 1 into in minus 2. So n here multiple will bring this side. In is equal to n minus 1 divided by n into in minus 2. After that, how to get n minus 2? In place of n, substitute n minus 2. So n minus 1 by n. In place of n minus 2 substitute. So keep bracket. In place of n minus 2 substitute n minus 2 minus 1 by n minus 2 into, in place of n minus 2 means in minus 4. I hope you understand, dear students. N minus 1 divided by n minus 3 divided by n minus 2. How to get n minus 4? In this formula, wherever n is there, replace with n minus 4 to get this in place of this only. So, into in minus 4. In place of n, substitute n minus 4. In this formula, n minus 4 minus 1 divided by n minus 4 into n minus 4 minus, in place of n we are substituting n minus 4, n minus 4 minus 2, n minus 6, that is equal to n minus 1 by n into n minus 3 by n minus 2 into n minus 5 by n minus 4 into, and so on, not only n minus 6 and so on. A I am writing. What is A? I am going to explain here, dear students. Okay. See what is A represents. Here A is equal to, if n is even number, integral 0 to pi by 2, at last you will get it as 1 by 2. Wherever it is n is even number, at last we will get pi by 2. So integral 0 to pi by 2, that n is equal to 0 means it comes sine, just simply writing as dx. Whenever integral dx is x, n is equal to even number. Generally 0 is not even number, but we can write it as n is equal to 0 is sine power 0, 1. Integral dx is x. Applying the limit 0 to pi by 2, you will get it as pi by 2. Next, integral 0 to pi by 2, sine power 1x. Integral sine x is minus cos x. Applying the limit 0 to pi by 2. So minus cos pi by 2, 0, minus cos 0, 1. So 1. When it will be, when n is odd number. So at last A value, in place of A pi by 2 if you are writing, if n is even number, in place of A if you are writing 1 if it is odd number. Therefore when we are writing, at last we will get pi by 2, at last we will get 1. So therefore we conclude that by successing this procedure, by continuing this procedure, we get In equal to n minus 1 by n into n minus 3 by n minus 2, n minus 5 by n minus 4 into, and so on, pi by 2. At last you will get 1 by 2. So pi by 2. If n is even, that is equal to n minus 1 by n, n minus 3 by n minus 2, n minus 5 by n minus 4, and so on, 2 by 3. At last you will get it into 1. If n is odd, even not compulsory to write this, till here only you can enough, dear students. A value, if you write like this, you will get full marks. There is no doubt about it, dear students. I hope you understand. Okay, dear students, I'll move to another question. Integral 0 to pi by 2 x by sin x plus cos x into dx is equal to pi by 2 root 2 into log root 2 plus 1. They are asking to show this result. integral 0 to pi by 2 x by sin x plus cos x is equal to pi by 2 root 2 into log root 2 plus 1. So first, the given integral as I, you can assume that. Let us consider I equal to integral 0 to pi by 2 x by sin x plus cos x into dx. You put that equation number 1 by using one of the properties in definite integration. Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x into dx. By using this formula, very important one, keep in mind, dear students. So I equal to integral 0 to pi by 2, in place of x, a minus x, a is equal to pi by 2 here. So pi by 2 minus x by sin of pi by 2 minus x plus cos of pi by 2 minus x into dx. So that is equal to integral 0 to pi by 2 minus x divided by sin of pi by 2 minus theta, cos theta, that means cos x, plus cos of pi by 2 minus x, sin x, into dx. Now we can split into two integrals, pi by 2 by this value minus integral 0 to pi by 2 x by this value. We can split it. So pi by 2 into integral 0 to pi by 2, 1 by cos x plus sin x into dx minus integral 0 to pi by 2 x by cos x plus sin x into dx. This is about I. From equation 1, this value is equal to I only know. So minus I seems from equation 1. So I equal to pi by 2 integral 0 to pi by 2, 1 by cos x plus sin x into dx. So minus I bring this side, 2I is equal to pi by 2. Are you able to see, all of you? Yes, good. 0 to pi by 2, 1 by sin x plus cos x into dx. From here, turn it step, dear students. Whenever a cos x plus b sin x form is there, dividing and multiplying by root of a square plus b square. Here a value 1, b value 1. That step I am going to do that. 2I is equal to pi by 2 integral 0 to pi by 2. Generally what we will do is from here onwards, sin x cos x in terms of tan we are going to apply. Instead of that, I am going to replace with a different method. 1 by sin x plus cos x. Here what I am doing is sin x coefficient 1, cos x coefficient 1. Dividing by root of a square plus b square. Here a value 1, b value 1. Root of a square plus b square. 1 square plus 1 square. So root 2. So dividing and multiplying with root 2. Here dividing with root 2, multiplying with root 2. Do you understand that? So 2I is equal to pi by 2 root 2 integral 0 to pi by 2, 1 by, here 1 by root 2 is sin x into cos pi by 4 plus cos x into sin pi by 4 into dx. Sin a cos b plus cos a sin b. Sin of a plus b. So 2i is equal to pi by 2 root 2 integral 0 to pi by 2 1 by sin of x plus pi by 4 into dx. Sin of x plus pi by 4. Sin a cos b plus cos a sin b. So 1 by sin cosecant. So 2i is equal to pi by 2 root 2 integral 0 to pi by 2 1 by sin is cosecant. So cosecant of x plus pi by 4 into dx. Integral cosecant x formula log mod tan x by 2. So 2i is equal to pi by 2 root 2 log of mod tan x by 2. X value is x plus pi by 4 by 2. So tan x by 2 plus pi by 8. Applying the limits 0 to pi by 2. Okay, dear students, we'll move on to the next step. So 2i is equal to pi by 2 root 2. First, in place of x upper limit, we are going to substitute. So log mod tan pi by 4 plus pi by 2 by 2, pi by 4 plus pi by 8 minus log mod tan pi by, so x is equal to 0 means tan 0 plus pi by 8. Okay, dear students. These two also will simplify and we will move it. 2i that is equal to pi by 2 root 2 log tan pi by 4 plus pi by 8. Anyone? Pi by 4 plus pi by 8. Root 2 plus 1 minus tan pi by 8. Root 2 minus 1. We'll do that next step, dear students. I'll rub this except the last step. I'm going to rub this side. We'll continue from there. So 2i is equal to pi by 2 root 2 log a minus log b, log a by b, log root 2 plus 1 divided by root 2 minus 1. So how to calculate this one? We have to do that rationalizing factor. So multiplying and dividing by root 2 plus 1. The rationalizing factor for the denominator, root 2 minus 1 is root 2 plus 1. So pi by 2 root 2 log root 2 plus 1 whole square by a minus b into a plus b, a square minus b square, 2 minus 1. So that is equal to pi by 2 root 2 log root 2 plus 1 whole square by 2 minus 1 is 1, we can leave it. So 2i. So log a power m formula, I mean to log a. So 2i equal to 2 pi by 2 root 2 log mod root 2 plus 1. Okay, dear students. Here 2 get cancelled. That is I equal to pi by 2 root 2 log mod root 2 plus 1. So what is I we consider? That is integral 0 to pi by 2 x by sin x plus cos x into dx is equal to pi by 2 root 2 log mod root 2 plus 1. Hence, proved, dear students. I hope everyone understand this. Tomorrow, if possible, I'll make 2 more sessions. I will take tomorrow means after 8 o'clock only, but because my college timing is different. If possible, 2 more videos also in definite integration. Sometimes all of a sudden they will ask some questions. Why? Because I face when we are teaching perfectly also sometimes the question paper setter will test us by giving different questions. Continuously 3 to 4 years they are asking easy questions. All of a sudden 1 year they will give different questions. So that time most of the students they will by observing the situation they will feel it is very difficult. So to bear the situation you need to practice tomorrow's or day after tomorrow what I am going to explain in these sessions. The different questions I will explain, dear students. Those who are watching, second year students, please inform to juniors also about our channel. Then we'll go on. Those who are watching, please like and share to your friends. Thank you all, dear students. Some students are requesting when the live sessions on hyperbola and parabola. Parabola, every question it is there in our playlist. Exercise wise 3A, 3B and 3C. I kept, including examples. Different methods also I kept, dear students. Based on my timings, I am explaining. You understand that? Thank you all. Jai Hind. After completing of this session, you can give comments. Yeah, Farhan, yes. Yeah, paper presentation also it is there. I will give in the link in the community tab. How to prepare 2B, how to prepare 1B like this. I already made last year. Based on the same situation, you will get it, dear students. Thank you all.